Ovulation and luteal phase. LH is necessary for the final follicular growth and ovulation. Ovulation in a woman who has a normal 28-day cycle occurs about 14 days after the onset of that menstruation. LH is necessary for the final follicular growth and ovulation. Shortly before ovulation, the outer wall of that follicular swells and a small area of the center of the follicular capsule, which is the stigma, begins to protrude. LH is necessary for the final follicular growth and ovulation. Without this hormone, even large amounts of FSH cannot cause the stage to occur. About 2 days before the ovulation, for some of these reasons we do not fully understand, the LH begins to secrete and increases, called the LH surge, which causes an increase in the formation of the antrum fluid that is inside the follicle. This increased pressure causes the fluid to force the secondary oocyte out of the follicle and expels it, which is referred to as ovulation. H and LH act synergistically to cause a swelling of the follicle. LH peaks about 16 hours before ovulation, and LH begins to target both the granulosa and theca cells, converting them into progesterone-secreting cells. The rate of secretion of estrogen begins to fall while increasing amounts of progesterone begins to be secreted. Several requirements are needed for ovulation. Number 1, there's a rapid growth of the follicle. 2, there has to be a diminishing estrogen secretion after this super long extended period of time of estrogen secretion. And now the progesterone hormones begins to go up. The role of LH surge. LH causes rapid secretion of the follicular steroid hormone that contain progesterone. Within a few hours, basically 2 events start to occur. Number 1, the theca cell externa begins to release these enzymes, such as lysozymes, that can begin to dissolute the follicular capsule and then eventually weaken the outer wall. This will then make the swelling a lot easier and degenerate that stigma. The second event is that simultaneous rapid growth of various blood vessels into the follicular wall. At the same time, chemicals like prostaglandin begin to be released and cause vasodilation, and they're secreted into that follicular tissue. So, 2 events that occur is the proteolytic enzymes like collagenases weaken the follicular wall. You also have the prostaglandin secretion leading into more blood vessels and swelling. And together, when the stigma degenerates, it causes the follicle to rupture and then the ovum to be released out. First few hours after expulsion of the ovum from the follicle, the remaining granulosa cells and the theca cells begin to change into what we call lutein cells. They enlarge in diameter to 2 or more times its previous size, and they're filled with these inclusions that make them kind of yellow, and that's mostly from lipids. This process is referred to as luteinization. And together with that cell mass and this kind of scar tissue, we call it the corpus luteum, which is basically this well-developed vascular supply that keeps on growing. And no, that is not a popcorn or a flower. The granulosa cells in the corpus luteum develop extensive amounts of smooth endoplasmic reticula, and they're able to form large amounts of the sex hormone progesterone and estrogen, with more progesterone than estrogen at the luteal phase. The theca cells mainly contain androgens and androstenedione and testosterone rather than female sex hormones because they lack an enzyme. However, most of these hormones are then converted via aromatase in the granulosa cells into estrogen. So as it regresses, it becomes what we call the corpus albicans, which is this white connective tissue of a scar. The granulosa cells begin to produce large amounts of progesterone and estrogen, and the theca cells form the androgens, but they are also converted to estrogen by the help of the granulosa cells because of the enzyme aromatase, also known as CYP19 enzyme. So in summary, the control of ovarian function is as follows. GnRH stimulates the secretion of FSH and LH. GnRH is secreted in episodic bursts. This burst is boosted and increased by estrogen, but decreased by progesterone and testosterone. There's a feedback loop to be aware of. In early follicular phase, FSH is modest. LH secretion is reduced because there's a higher and rising amounts of estrogen. Estrogen gets higher about 36 to 48 hours before ovulation, which is a positive feedback. And then the LH boosts up, which is going to be the surge that leads to the pushing and the expelling of the ovum. FSH is also still pretty high, and then the regression of the corpus luteum begins to cause estrogen and progesterone to drop down. FSH, LH becomes modest again, and the cycle repeats itself again. Here are some visuals to help you understand that concept. This shows you the process of mitosis and early oogenesis from the oogonium into the primary oocyte. it's arrested in prophase 1. Childhood, it is in pause in meiosis 1. The primary follicle is going to grow into the secondary follicle during the monthly cycles. Throughout the puberty to menopause, becomes the antral follicle, which is a lot larger, a lot thick layers of theca cells and granulosa cells. And then the secondary oocyte, where you can see a mature follicle and the antrum, the fluid-filled space with a lot of hormones. And then eventually the rupturing of the egg from the follicle, and the corpus luteum, and then eventually corpus albicans. Here's a histological comparison to those. And then eventually, if the egg is fertilized by a sperm, then the meiosis 2 will then continue and the division goes on. Here is a comparison of the levels of hormones in a typical 28-day cycle. So the primordial follicle is the early stages. In the midpoint of the cycle, we have the secondary follicle, and then we have the mature follicle. Most of the follicles spend their time in the preantral stage, 290 days of the year, and the antral stage is about 65 days in the year. Looking at this graph, you can see that the hormone levels of FSH peak up along with the LH right before ovulation, and they spike substantially higher than any other time of the month. That peak is going to push the ovulation and kick the two events to occur, the blood vessel and prostaglandin, as well as the weakening and enzymatic digestion of the wall. On the bottom, you can see a comparison of the estrogen progesterone levels of these hormones. Progesterone shown here spikes up as well right before ovulation, dips down, and then begins to climb up again towards the end of the cycle, whereas progesterone is only rising in the later period of the cycle. Its main function is to maintain the uterus for implantation. You can see how the changes of the uterus coincides with the increasing amounts of progesterone.